Okay, so we have talked about inference gathering, or we've talked about gathering data through our senses, through numbers. We've talked about observing different things that we see. We've talked about creating a hypothesis or drawing a conclusion. Now, the biggest thing that we need to do is we need to figure out how to organize that data. So, as a scientist, the biggest thing to do, even if you have the raw data, you need to organize that data in order to best figure out a way to have another scientist read it. So in our case, if you don't have your data organized in a way that I can read it, I can't give you a grade. So that means you don't get a grade for your project or for your experiment or anything along those lines. So it's important that you find the best way to organize your data. So there are different ways that we organize data. The two biggest that I would suggest are graphs and tables. As long as they're matched up pretty well, that gives you the ability to show your data in an organized way. So graphs are your graphically organized. They're easy to see. It's a visual. Now data tables, they are going to be headings, units, data. They're going to show you how you organized and how you made your graph. So there are different types of graphs. There's bar graphs, line graphs, circle graphs. A little more time for you to see that. So pie graphs or circle graphs are like pieces of pie. There are bar graphs, of course, stacks of coins, stacks of lines, and then line graphs where it shows like a turn on the road. These are the most common graphs that you'll see when you work with it in different areas of science, different areas of life. So a line graph is the most important one when it comes to science. That's what you will use more often than not. So your horizontal axis is your x-axis. This is your independent variable. Your dependent variable is your y-axis. So remember, independent is what you're testing. Dependent is what changes based on your independent. So y-axis is going to be your dependent. X-axis is independent. Y-axis is dependent. X-axis is independent. You use this kind of graph in math, but in ours, you will only use the positive quadrant. So y-axis is your dependent. X-axis is your independent. Notice I am repeating this over and over again because this is what you need to know when you create a line graph. You have to have your dependent on the y-axis. You have to have your independent on the x-axis unless it is a unusual occasion. So every graph needs a title. If you do not have a title there, I don't know what you're talking about. It is just data that has no specific organization. Organization is how you get grant money when you're a scientist and how you get a grade when you're a student. So a title depicts what it is about. It needs to be a short statement. It doesn't need to be a paragraph to tell me what you're talking about. So your independent variable is what is controlled by the experimenter. This is usually time, depth or length, temperature, and that is something that is able to be controlled. This is placed on your x-axis. Remember, independent variable goes on your x-axis. The dependent variable is something that is directly affected by the independent. Remember, dependent depends on the independent. So this is the result of what happens. So how many inches something grew, the number of oxygen bubbles produced based on a temperature, how fast something happened based on a temperature or a time. This is placed on your y-axis. Remember, y is your dependent variable. Y-axis is your dependent variable. So direct relationship is when your x-axis gets bigger, your y-axis gets bigger. So that means there is a direct relationship between age and size of a plant or an animal. That is an example of a direct relationship. And indirect means that as the x-axis gets bigger, your y-axis gets smaller. So think about the temperature. As the temperature goes up, the solidity of a piece of ice goes down. that type of thing. Or if you look at the relationship between the time spent in a mall or the time spent online shopping and the amount of money that you are able to spend. Dynamic equilibrium means the two variables are equal to and opposite of each other. So think of as things move on, you're going to have the equal and opposite thing happen to each part of the axis. And then cyclic is a repeating pattern, or cyclic. So you're direct, everything's moving upwards. Indirect, everything's moving downwards. And cyclic, so like how your waves move. So for those of you that are in earth science, we deal with cyclic relationships more often than anything else. So think about high tides, low tides. Think about the phases of the moon, the length of a year, the amount of time in a day. The temperatures go from cold to warm each day, cold to warm each year, and then they go back to cold. Same thing happens with the movement of the plate tectonics. These are all directly related. So remember, y-axis is your dependent, x-axis is your independent. All right.